All right, so here's the trig stuff. 101, you get your sine, cosine, your tangent. That's going to be sine, cosine, and tangent of an angle. That's going to be called theta. And the ditty is SOHCAHTOA. SOHCAHTOA. As in sine of theta is equal to the opposite side of the angle of theta divided by the hypotenuse. Cosine of theta is equal to the adjacent side, or the side next to the angle theta, divided by the hypotenuse. The tangent of theta is equal to the opposite side of the angle theta divided by the adjacent side of the angle theta. So as in sine equals opposite over hypotenuse. Cosine, ka, as in cosine equals adjacent over hypotenuse. And toa, as in tangent equals opposite over adjacent. So any right triangle here that you're going to be working with, it's going to have 3 sides and 3 angles. The sum of the 3 angles, boom, 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 ABC, angle A, angle B, and angle C are 180 degrees. And your angle C will always be the 90-degree angle, and that's a little c, that's a big C. Little a, little b, big B. So the angle little a corresponds to the side that's opposite it as big A. And same goes for B and for C. Now we have another note here that big A squared plus big B squared equals big C squared. That's telling us that the length of this side squared plus the length of this side squared is equal to the length of this side squared. Okay, so let's do the sine. The sine goes with the inverse sine, so there's 2 functions that we'll use. We'll do those on the calculator in a second. So you have sine and inverse sine. On the calculator, you have sine and inverse sine right there. You would use the sine when you're given an angle and a side, and you'd use the inverse sine when you're given 2 sides. So let's look at an example. Here's our right triangle. We have our little a, little b, little c, big A, big B, big C. Our angle theta is 20 degrees. So in this case, our little a is equal to theta, which is equal to 20 degrees. And we want to solve for the length of side C. So this is a sine example, so remember the ditty. SOHCAHTOA. Sine is opposite over hypotenuse. Here we have an angle. We have the opposite side, and we have a hypotenuse. So let's go ahead and plug in our sine formula from up here, down here. Sine of 20 degrees, because theta is 20 degrees, so sine of 20 is equal to the opposite over the hypotenuse. So that's, bring it down, sine of 20 degrees is equal to the opposite, which is 15, divided by the hypotenuse, which is C. So then we'll go to our calculator, we'll punch in sine of 20, 0.342. So the sine of 20 is 0.342. And then we would just bring our 15 over C right down. Then we're gonna multiply both sides by C, which will cancel the C's on this side, and it will give us with 0.342 C on the left side is equal to 15. Then we just divide both sides by 0.342, and we get C is equal to 43.86. So the length of this hypotenuse side here is 43.86. Let's look at another example. Same, right triangle. Little a, little b, little c, big A, big B, big C. In this case, though, we're actually given 2 sides, and we want to solve for the angle A. So we're going to use the same formula, the sine. It's going to be sine of A is equal to the opposite over the hypotenuse, or 20 divided by 29. We'll bring sine of A down, and this is just a fraction, so we can do the division. We get 0.69. Then we're going to multiply both sides by the inverse sine, and that will cancel out the signs here, and it'll leave an inverse sign over here. So A comes down, sine of negative, sine inverse of 0.69. Let's check it on the calculator. So it's second sine for inverse sine of 0.69. 43.63. 43.63. Okay. Next we'll do cosine example. I'm going to go through this really quick because it's very similar to the sine one, except instead of using the opposite side of the angle, we're going to use the adjacent side. So all of that algebra is more or less the same, just instead of using opposite, you're using adjacent, because cosine is ca, C-A-H, as in cosine of theta is equal to adjacent over hypotenuse. So in this case, we get our side C at 12.94, and if we'd been given the two sides instead, then we would just solve through and use the inverse cosine, just as we did with the inverse sine in the previous one, and alpha in this case is going to be 39.01 degrees. The tangent and the inverse tangent. First example, same setup. We're given an angle, but instead of a hypotenuse and a side, we're given an unknown side, opposite side, and a known adjacent side, or these could be reversed. We would just do same way through. Tangent is TOA, T-O-A, as in tangent of theta, 26, is equal to opposite over adjacent, so A over 18. We do our calculation in the calculator here. We bring this down, we do the math by multiplying both sides by 18, and we get A is equal to 8.78. That's this length here. If we had been given two side lengths and needed to solve for the angle, then we would just do the same process through and then use the inverse tangent, multiplying both sides by it, canceling the tangents on the left, and retaining the alpha variable, little a, is equal to 21.8 degrees. Okay, the Pythagorean theorem is that little note we had at the beginning, big A squared plus big B squared equals big C squared. That's telling us that the A and the B sides are each going to get squared, added up, and then compared to the square root of C. Let's look at that. A, 17. 17 squared is 289. B, 10. 10 squared is 100. 289 plus 100 is 389. C squared is C squared is C squared is C squared. And now we just take the square root of both sides to get rid of this little guy. And we're left with C is equal to 19.72. In that case, we knew the opposite and the adjacent sides, and we were solving for the hypotenuse, but maybe you have to solve for an opposite or an adjacent side. The formula is still the same. A squared plus B squared equals C squared. A is 65. 65 squared, 4,225. B squared is B squared. C is 107. 107 squared is 11,449. We subtract 4,225 from both sides, and we're left with B squared is equal to 7,224. Then we take the square root of both sides to get rid of this little guy, and we're left with B is equal to 85. All right, so let's solve an example from scratch. Solve for all side lengths and all angles. So there's 3 side lengths, 3 angles, so we should ultimately end up with 6 answers here. We're given an angle and a side, and this triangle is in a different orientation, but let me show you why that doesn't matter. We have an angle and an adjacent side. And we're going to be looking for big C right here. So we know that little a is equal to 64 degrees. Little b, therefore, is equal to 26 degrees, because little c is equal to 90 degrees. And these need to be equal to 180 degrees. So I knew this was 90, I knew this was 64, I added them up, took the difference off of 180, I'm left with 26. Now the side lengths, A, B, and C. So that was 64, and so this is 26. Okay, let's go after it. Let's find side C by saying we have an angle alpha and an adjacent side. So that's going to be ca, because it's cosine of theta is equal to adjacent over hypotenuse. So we'll say cosine of 64 degrees is equal to the adjacent over the hypotenuse, and the adjacent is 3.4, and the hypotenuse is just big C. The cosine of 64 is 0.438. So it's going to be 0.438 equal to 3.4 divided by C. Now let's just multiply both sides by C. And these ones will cancel. This one will retain over here. So we'll have 0.438 C is equal to 3.4. And now we'll just divide 3.4 divided by 0.438. So that's 3.4 divided by 0.438. And that looks like 7.76. So 7.76. Up here, this is 7.76. Okay, so now the only one that's missing, because A is 3.4. Wait, no. Sorry, B is 3.4. Because it's the adjacent side. A is unknown. C is now equal to 7.76. 7.76. All right, so now I want to solve for A. We could use our knowledge of this angle of 26 and do it by way of sine to find this, but the faster way is just to do the Pythagorean theorem, because we have only one unknown on our side, so that was A squared plus B squared equals C squared. A is unknown, so that's going to be A squared plus B is 3.4, and 3.4 times 3.4 is equal to 11.56. It's equal to C squared. C is 7.76. 7.76 times 0.76. 60.22. We'll subtract 11.56 from both sides. And we'll be left with A squared is equal to 60.22 minus 0.56 is equal to 48.66. So now we just got to get rid of this little squared. So we'll take the square roots of both sides. That's going to tell us that A is equal to we could say second square root of 48.66. 6.98. So that was 6.98. And there we have it. All angles, all sides. Full solution. So here's another example that you can try if you like. And the bonus was to verify with Pythagorean theorem, which we did up here. So in this one, let's take a look real quick. We have two sides. We have little angle A and a little angle B and a little angle C, which means we have a big B over here. And we have an A right here and a C right here. Okay, so 8.8 and 7 root 2. Let's just go ahead and make this easy on ourselves. So that was 7 times the square root of 2. That's going to be equal to 9.9. Okay, so in this case, if we want to solve for angle A, we have an opposite and a hypotenuse. Opposite hypotenuse, O over H. That was SOH, S-O-H, sine of angle A is equal to the opposite over the hypotenuse. So we can say sine little a is equal to the opposite, which is 8.8, divided by the hypotenuse, which is 9.9. And then we'll be left with sine A is equal to 8.8 divided by 9.9 is 0.89. And then we'll do the inverse sine multiplication on both sides. Sines will cancel. A is equal to the inverse sine of 0.89. So I come over here and I say second inverse sine of 0.89. I get 62.87. And that's going to be degrees. So this one, 62.87. Now, if I know this one is 62.87, and I know this one is 90, right? We can get our solutions up here. 62.97. B is unknown right now. Little c is 90. All I got to do is say, I'm sorry, 62.87, not 97. 62.87 plus 90 minus 180. 27.13. B is 27.13 because this was known, and all of them have to be equal to 180. Okay, so there's our angles. Now let's do our sides. A equals, B equals, and C equals. Well, we already have some information here. A is 8.8 and C is 9.9. So we're just going to use the Pythagorean theorem again. We're going to say A squared plus B squared equals C squared. And A is 8.8, so 8.8 squared is equal to 77.44. We don't know B, so that's going to be plus B squared is equal to C squared, which is 9.9, and 9.9 squared is equal to 98.01. So now we're just going to subtract 77.44 minus 77.44. B squared is equal to 20.57. Now we just have to get rid of this exponent by squaring both sides. And we find out that the square root of 20.57 is equal to 4.54. So B is equal to 4.54. Okay, cool. Oh, this was just a verified answer, which we already did on the first one. Okay, so this is just a quick overview of the proof of how this inverse sine and sine thing works. If we let the function sine be equal to the letter lowercase n, then we would say the inverse of this lowercase n is n to the negative 1. And anything to the negative 1 is equal to 1 over that thing. So that's the same as saying the sine of negative 1 is equal to 1 over sine. So from our first example, we went through it already, but here's the math slower, and I interjected exactly when, here's where we multiply both sides by sine of negative 1, boom, and boom. And then we say, look, you can cancel these sine terms because sine of negative 1 is equal to 1 over sine. So this sign would cancel in the denominator with this sign in the numerator, leaving you with just the lowercase a. And over here, you'd be retaining the sine of negative 1 is equal to 1 over sine times a. Oh yeah, that's the a. And then over here, you'd be retaining sine of negative 1 of 0.69. Put that in the calculator, and we get our little angle a is equal to 43.63. All right, that's your basic trig.